All right, welcome. I'm Jeffrey Snover, distinguished engineer and lead architect for Windows Server. Forgive me, I did a keynote demo this morning, and this is my third back-to-back session, so I might be a bit off today.
His fourth session of the day. I'm Rafat Issa. I'm a program manager on the PowerShell team.
So we're going to talk to you about how to use the Windows Management Framework to manage a highly efficient environment at scale. Here we go. Okay, so first you want to talk about why we're doing this, and I like to explain the motivation behind things so that you can understand why we do things, and then it helps you predict what we're going to do next and what's important to us. So with Windows Server 8, Windows becomes, we have a shift, right? It's what I call a pivot release. We used to be this, and we're changing who we are, right? We're expanding it, really. In the past, Windows viewed itself as a great great OS for a server and for its devices, okay? Now, going forward, Windows 8 focuses on being a great OS for lots of servers, the devices between them, whether they're physical or virtual, whether they're on-premise or off-premise. So, Windows Server 8 is a cloud-optimized OS, okay? So, being a cloud-optimized OS, you need to do things differently, okay? And so that's what this talk is about. The Windows Management Framework has been modified. Windows Management Framework has been out there for a while. It consists of PowerShell, WMI, bits, things like that, and WSMan. And we've modified that, and we've modified it in order to meet the needs of a cloud-optimized OS. So first I want to talk about how a cloud-optimized OS requires a different management user experience. And I'll give you a brief demo of that user experience. Actually, I will log into the network and give you a brief view of that experience. My VPN went away. Rafat, talk to them for a second.
All right, so this demo is about Server Manager. Server Manager is a great rich GUI for Windows Server 8, but please remember that this is just a thin layer on top of the Windows Management Framework that we're trying to describe in the session. This is at the very top layer. At the bottom, we have our APIs, we have SMIS, COM, DCOM, .NET, sitting on top of storage, disk, Exchange, SharePoint. Above that, we have the automation layer. We have the engines layer. PowerShell engine. Are we done? No?
No.
The PowerShell engine, WMI, and the workflow engine. They're exposed through HTTP, either directly through something like POA, for example, PowerShell Web Access, or over OData and WSMan. At the very top, on top of all of this, this is where Server Manager lives, the ISE, the Integrated Scripting Environment, Power GUI, and all the management solutions.
Thank you so much, Rafat. So this is the new Server Manager. It's clean, it's fresh, sports a Metro style. Down here, up here you have your day zero experience, a quick start, shows you what's new, where to get more information. You can hide this after your day zero. You're left with our dashboard, live tiles for multi-machine, multi-role management at what we call a glanceable interface. You can look at this and at a glance understand your situation. Is there anything that requires your attention? Notice that anything that does gets highlighted in red and you're drawn to it. You can then select instead, gone is the action pane where you had to select something and go back and forth and back and forth. All actions happen on the objects as you select them. So as I click on services, I see that there are these 4 services that should be running that aren't. I can select one and start it, or select all of them and start them. That then runs in the background. This provides me, and as it resolves, this user interface gets cleaned up. Here, I can click on All Servers and drill into an All Servers mode. Having selected the full server node, I see the events for that full server node, its services, best practice analyzer, a new performance alerts tile, and then the features. So this is very similar to the existing Server Manager home pages, but with a difference. And the difference is here at the top. At the top, we have multiple machines. So here, you see, I'm showing you the services for full server. If I click Workflow Host, You see I see the services for workflow host, and I can select multiple machines or all the machines. And when I select all the machines, I now see all the services for all the machines. I can do things like click to sort. I have rich features here to do SQL type queries. I can do filtering, quick ad hoc filtering here. Yeah, Hyper-V. Anyway. And I can do things like Hyper-V, yes. Group them by display name. So here I'm seeing 5 things have Windows Installer, and I can still sort it. 2 things have Active Directory domain services. So the new Server Manager is a multi-machine, multi-role server manager designed for a cloud-optimized operating system. Now, the reason why I point this out is if you wanted to go and reproduce that, it would be actually very easy for you to do. It'd be very easy for you to do because of what Rafat was explaining, that this is in fact a very thin layer, a very thin GUI layer on top of the new multi-machine capabilities that we have added to the Windows Management Framework. And that's what we're going to talk about. There you go. Oh, so indeed, this is designed, this new Windows Management Framework is designed to minimize the cost and effort to create robust multi-machine management solutions. Robust is a key word here. Whenever you have multiple things that are connected, whenever you have multiple things, you're guaranteed some of them are going to be failing. And the question is, when you try and perform an operation on a set of things, some of which are down or will fail, what then must you do? And there's 2 answers. One is fail, generate an error message to somebody above you, and let the user figure it out. That's not an acceptable solution. Instead, the framework itself should be able to deal with these errors, retrying, etc. And that's the approach we're taking. So this is what I like to call the big animal picture describing the Windows Management Framework. At the bottom is the messy world that you have to manage, right? In a cloud-optimized OS, you need to be able to manage everything. What, is this you?
Next one.
You need to be able to manage everything. You have messy stuff at the bottom. You need to be able to storage, networking, etc. You have different APIs. The world always has been, is, and always will be a messy place. Messy because things already exist and they don't implement the standards. Things implement the standard, but you're working with the previous version. Things are happening very quickly. They're innovating, and so they're not taking the time to implement the standards, or there isn't an appropriate standard. So the world's always a messy place. We try and get it to a place of standards-based management, but you need to deal with the messy world. On top of that, we provide order to a messy world. We provide order with our management engines, WMI, PowerShell, and Workflow, and provide a uniform management experience of this messy world to you locally or remotely. Remotely via standards-based management. Well, first, over HTTP and HTTPS, so protocols that can traverse firewalls, deal with high latency, just great protocols. And then you can surface that through standards-based management, WS management, or the new more ad hoc web-oriented APIs, the REST APIs, and we implement a OData API. OData is really just a set of conventions on a REST API. And then you have a set of management tools that run remotely. One of our themes that we're trying to be very explicit and clear with people is that starting with Windows Server 8, the preferred configuration is now Server Core. Full server is provided. Full server, you can still have all your GUIs, etc., and that's provided as a compatibility environment only. The goal is to get all server applications to run without a GUI and produce GUIs. We love GUIs. Just run them on the client and use our protocols to do remote management.
Awesome. Thank you, Jeffrey. So what problem is the Windows Management Framework solving? I think we touched upon that in the previous session as well. We have the N by M problem. We have solution developers, management solution developers who are trying to code against M different devices. Jeffrey mentioned in the previous session the Intel vPro chip, where Intel would be at the bottom, one of the IHVs. They produce managed elements. And they now have to go find solutions that work on their technology. This is the N by N problem we're trying to solve. The solution is to have a Windows Management Framework to which all of the IHVs, ISVs, managed element producers produce commandlets, WMI providers, and enrich the ecosystem of the Windows Management Framework. And all the solution developers at the top can actually leverage this plethora of commandlets and build their solutions on top of that. And this totally abstracts their having to know each and every detail about each and every managed element. And instead, whenever a new managed element plays nicely with the ecosystem, your solution already works against it.
Yeah, a great example of that is right here we have Dimitri, who is the chief architect and inventor of Power GUI. If you're not familiar with it, you should become familiar with it. It's a wonderful tool, and it allows people to create their own management GUIs that talk to PowerShell commandlets. Okay, now vPro came out with a set of PowerShell commandlets, and they were able to take advantage of his tool with no extra effort, just because they're just commandlets. And his tool got better because now people could use it to manage vPro hardware. The new version of Windows Server 8 goes from basically, 230 commandlets to over 2,330 commandlets. And all of those plug into Dimitri's tool seamlessly. So his tool just got a ton more valuable. And so that's the benefit of like the self-amplifying ecosystem.
A cloud-optimized OS requires formal and informal management. I think Jeffrey just mentioned the messy world. When he was describing the Windows Management Framework, he said at the bottom, the APIs, SMIS, COM, DCOM, all the storage, Exchange, SharePoint, this entire messy layer, he's saying that the layer above it, the engines layer, and the Windows Management Framework layer, PowerShell, WMI, and workflow, provides that order. Well, the world is a messy place. In other words, if we all had formal management, if we all had standards-based management, that would be great. But this is not reality. Reality is, I cannot wait until the standards come out. I have a solution that doesn't work with it. There are incompatible devices. This is the reality of things. So we always need a mixture of formal and informal management.
And it should be clear here, Windows and Microsoft is pushing formal-based management very, very heavily. You'll see that.
It's great when you have it. It is great when you have it.
Yep.
The Windows Management Framework is not just for developers. We'll show you some of the APIs we have that make consuming commandlets, workflows, locally or remotely, very easy. So you can write your solutions much faster, much broader. But even scripters can contribute to the Windows Management Framework through script commandlets, through script workflows. That actually, what do you call the relationship between the IT pros and the developers?
I don't remember.
Oh, so basically, I think I think it was you I talked to about that. But the IT pro and the developer can basically work together on a solution. I remember from when I was in consulting services, there used to be a big disconnect. The operations guys, the
DevOps.
IT pros, DevOps, you were talking about DevOps, yeah.
DevOps.
The IT pros, the operations people know their area very well, but they're not developers. They have to go and explain to somebody who is a pure developer, great at what he or she does, but they know nothing about operations. They know their code and that's it. And that always created a disconnect. To amplify that, they used to bring consultants in to actually explain that world to this world. With this model, you actually don't even have to do that. They can work together seamlessly. An IT pro can use scripting experience to develop a prototype to tell the development team exactly what they want. They can actually work on this together.
Yeah, and the other example, Dimitri's product, Power GUI, right? It goes and talks to all these commandlets written by professional developers. Wonderful, wonderful. But in PowerShell version 2, regular IT pros could write a script that was a commandlet as well. And so now any of the scripters can plug into the Windows Management Framework and his tool will be able to consume them. So it's you get the best of both worlds with this model.
Windows 8 provides the best cloud-optimized management platform with great new standards-based APIs and commandlets.
So basically, in the past, we had implemented WMI.
Sorry to interrupt.
And then we provided.
This is a green slide, so these are Jeffrey's signature slides. So.
So we had WMI, and now we had WS Management, and it was great, but we didn't implement the latest standards. So starting in Windows Server 8, we're fully up to speed on the latest DMTF standards. We have full and complete implementations of WS-MAN, and now WS-MAN is in fact the primary protocol to do remote management with with Windows. So DCOM is still supported for down-level machines. It's still supported for up-level machines, but the default is WS Management. So I like to say, how do you make something successful? And the answer is you rely upon it. In the past, honestly, we provided WS Management, and if it worked, that was great. If it didn't work, well, it didn't hurt us. Yeah, you use DCOM. In this release, if WS-MAN doesn't work, we don't work. And guess what? We're putting a lot of effort into making it a very high quality, very fast, very robust, production-oriented stack. Okay, so this is the new SIM interface. Now, in the past, we had the DCOM interface, and it would not talk to non-Windows devices, right? Routers, hardware, they don't know anything about DCOM. Then we had the WS-MAN interface, and the WS-MAN interface would talk to those things, but it wouldn't talk to DCOM devices. And frankly, that interface was not, honestly not one of our best interfaces. You'd invoke it, you could do operations, but you get back an XML document like, good luck, friend, here's XML. And if you've ever programmed against XML, it's painful. I like to refer to it as like trying to kick a dead whale along the beach. You can sort of it's hard. Anyway, so we now have a new approach to this. We have a new API to be able to manage standards-based management. It will work across DCOM or WS-MAN. It is native and it is managed, and it's a very nice interface. The .NET interface supports the latest .NET patterns, iObservable-T, cancellation tokens, all that great stuff. Okay, so here's an example of the old WMI API. You use a management scope, you connect to a particular namespace.
You just have to remember so much. There are so many different things you have to remember just to do a query operation.
Exactly, so pretty complex stuff. This is the new SIM interface. You do a SIM session, and by the way, the abstractions we've now switched, and there was WMI, and then there was the standard SIM stuff. And the abstractions were very close, but they weren't aligned. In this new API, we align to the SIM standards. Windows 8 is very hardcore on implementing the standards. So this new API matches the standards. You create a SIM session, created to that remote machine. You do session.query instances asynchronous. You give a namespace, a query dialect, the query you want. That returns an iObservable of SIM instances. And then we have this observable pattern, which says that results, you say subscribe to this, and then you have three methods: on complete, on error, and on next. And that asynchronous query will go out and grab all the objects, and as it gets an object, it will call the on next, and you can operate on it. Now, this is actually pretty simple code. You'll code it and you'll find out it's really easy to produce. The nice thing about this approach is, because it's asynchronous, imagine I'm going to perform a query against 100 machines. Now imagine those 100 machines aren't right next to each other, they're across a wide area network. Well, if I do that with a wide area network and I do synchronously, I invoke the call, I wait, get it, and then I do the next one, wait, get it. All the latencies just stack up, and it's going to take forever. Now consider I do 100 asynchronous calls. I issue 100 calls, there's a wait, and then all of a sudden, 100 of them will be streaming their results back to me asynchronously. So all the latencies, instead of stacking up, Anyway, they kind of cancel each other out. You just incur that cost once. So it's a very nice API. Now, this is using, by default, it uses WSMan. If you decided instead you want to use DCOM, that's what you do. You just provide DCOM, the thing in the red. So it's a very nice, clean API. So let's show you that. Okay, this is a GUI. I'm going to connect to a machine. I'm going to connect to local host. Administrator. I'm going to connect. Okay, now connected. I'm going to get a Win32 service from this namespace. I can enumerate it synchronously, get those results. I can enumerate asynchronously, get the results. I can have a query, select star from Win32 service, whose name starts like this from that. I can do a synchronous query, very, very quick, or an asynchronous query, very, very quick, and I'll hold off on the eventing for a second. Now, if I wanted to, I could do exactly the same thing over DCOM. And
did you check the connection?
Yeah.
I can't see the bottom of the screen.
Connection failed.
We have to wait for it.
Well, okay. Demo gods aren't with me. Pay no attention to that. Let's walk into the code. So this is the connection click. And you'll see, let's see, that looks a little small. Can you read that? Somebody in the back row, can you read that? Yeah? Okay, great. So this is a connection link. You grab the text box and you do here, you get either, if it was DCOM, you create a DCOM sessions or a SIM session. You get a set of credentials, SIM credentials. You give the server, the username, the password. And you take those credentials and you add them to the options. Then you create SIM session, you create it, given the computer name and the options. And then here we test it to make sure that it succeeded, and we continue.
Yeah.
Now, when I go and I do an enumerate async, okay, here I take that SIM session that I created and I enumerate instances async. I give the namespace and the class, and I get an iObservable of SIM instances called asynchronous results. And to asynchronous results, I subscribe the enclosing class. So when I do that, then I have iObservable.
You have your on errors and.
Where is it?
I saw it flash by here, uncompleted, on error, and on next.
That's the SIM subscription result.
Oh.
Here, let's do this. Using the amazing keyboard. On next. Nope, what did I do?
Check for next.
Oh, on next, sorry. There you go. It's as simple as this. You take this, you get a SIM instance of value, and you have because it's asynchronous, you want to execute it on the UI thread, and you add an instance to the grid. Add an instance to the grid is right here. You get the SIM value, and you fill out the rows by taking this. You get the columns. You grab each one of the columns, and you take the value. It has properties. You get the name, and you ask it for the value. So it's a little bit chewy, but it's actually very, very simple once you get used to it. Okay? And if you wanted to do this synchronously, it's even easier. Enumerate sync. Okay? You enumerate a SIM instance. You enumerate the instances, giving the namespace and the text. This time, you still get SIM instances back, but you get an IEnumerable. And then you just do a for each SIM instance in results, add instance to grid. So it's a very, very, very simple programming model. Now, how many people have written WMI provider or written code that consumes WMI in the past? Yeah, okay. So I think you will find this to be very easy to pick up. And again, the nice thing is this same APIs can work against DCOM, against WSMan. WSMan is the preferred way to do it. WSMan will be on by default in Windows Server 08. Okay, why on by default? Again, stems from our vision. That's why I like to give the vision and what motivates us. We are going to see ourselves as a cloud optimized operating system for lots of servers. When I have lots of servers, I'm just going to plug them in and I need to manage them. I don't want to have to walk up to a server and enable remoting. I mean, that just wouldn't fly. That worldview is consistent with an operating system that sees itself as being a great operating system for a server. That's not the deal. We're a great operating system for lots of them, so the remoting has to be absolutely secure and on by default. So that's what we're doing.
Back to slides.
Yes, please. I think you just need to do one.
It just didn't line up. Okay, I looked at this slide. This is one of those green slides. I told you the Jeffrey green slides. I looked at this. Windows 8 makes it easy to develop solutions that work even when the world is falling apart. Now, I love PowerShell more than the next guy. I love PowerShell with a passion. But when the world is falling apart, I don't think PowerShell is going to be the first on my mind.
Yeah, I like to say that, again, when you have a multi-machine world, things are always falling apart. If the management system doesn't work when the world's falling apart, you've built what is effectively the equivalent of a solar-powered flashlight, right? Only works when in direct sunlight. That's useless. The management system is what you rely upon when things go pear-shaped. So the management system has to be the one that works when everything's broken.
Let's talk about the PowerShell API just to lead up to the first demo, or second demo rather. We'll take a look at how to do remote management through PowerShell using the API. In V2, we already provided remoting through commandlets and the API, one-to-one remoting, fan-out remoting, and fan-in remoting. And new to Windows 8 and Windows Server 8 are robust connections. Jeffrey talked about those earlier.
Nope, I didn't.
Connections that do retries? We did?
Yeah, no, we
that
didn't
was the
discuss
previous
that.
session.
We talked about retrying an operation. Mm-hmm. These are robust connections. A robust connection says, hey, when we do this WS management, we use HTTP. Underneath the covers of HTTP, it sets up a TCP socket. Okay, and when that TCP connection encounters a problem, it will do a retry. It will retry, and then it'll say, it's not working, and it will fail. And then the HTTP will say, hey, we have a broken session. We can no longer connect. From a management perspective, that's goofy. It's like, no, my friend, work no matter what. So even when the TCP connection breaks, we will go and we will try and establish additional, we will retry that TCP connection for, I think the default is 3 or 4 minutes, and you can configure that to make it quite a bit longer.
The timeout and the retries are configurable.
Yeah, because things happen, right? I'm here, right? Hybrid clouds are very important. Guess what? Hybrid clouds means I'm here and the stuff I want to manage are way over there. And being way over there, boy, there's lots of things that can go wrong. Again, you want it to just work.
What we also added in Windows 8 is remote disconnect and reconnect. It says connect, disconnect. This is just easier to say. But in fact, we have 2 distinct scenarios that are very valuable. The first one is disconnect. I'm doing something on that remote machine or those remote machines, and I want my thread back. I don't care for this is a long-running operation. I want control back. And I want to reconnect to those remote sessions from my same session, to those remote endpoints from my same session. That's scenario 1, very valuable. The second scenario is you're at work, you're connected, you launched a whole bunch of jobs on remote machines, you disconnected your session, you went home, and you reconnected to those same remote machines, to those same remote endpoints from home. It's actually not a reconnect, it's a reconstruct. So this is going to enable you as solution developers to write some really awesome management tools.
Yeah, and it's not just robustness, it's also scale, right? So when you want to perform, we're a multi-machine management environment. In PowerShell version 2, we tested this up to, what was it, like 16,000 machines, Worked really well. Here, however, at that point, there's only so many connections you can have open. Say you wanted to manage 100,000 machines, right? Having 100,000 open sessions, that can be pretty tough. So so now the new framework can support that. What you can do is you can fire off a request to go do it, disconnect, fire those 100,000 off, and then at your own pace, whenever you want, connect to whichever machines you want, get the results, tear down those connections. So you might only have 1,000 connections open at any given time, even though you have operations on however many machines you want. Yeah. So this is what I mean by, and it helps you get a feel for the scale. So when we say multi-machine, we're not talking two.
2 or 3,
Yeah.
Workflows is also one of the things we added to the API, and job scheduling. We're going to see an example of all 3 of those. And there's also perf improvements. So you can look forward to a 6-fold perf improvement through on-the-fly compilation of PowerShell.
Yeah, we are super excited about this, crazy excited. I mean, basically, a lot of people always got PowerShell wrong. They thought of PowerShell as a command line interface. Never was. PowerShell is an automation engine that has a command line interface, but it's a DLL, it's an automation engine. That's why we're able to run graphical interfaces. Exchange Management GUI was always layered on top of PowerShell, so the performance was actually always pretty good. Here we've taken that, we took the script engine, the parser and the script engine, and we've completely replaced it. We use the DLR, and we actually do on-the-fly compilation. We use the script for a certain period of time, and at some point we say, hey, you're using that a lot, let's compile it on the fly, and then it just zooms like the wind. So very, very fast. Now obviously, we just changed our runtime execution engine. So we are very interested in any reports of, hey, this used to work in version 2 and it doesn't work in version 3. We want absolute compatibility, except for those areas where we said we're going to break this, but they're very small and very fringe, and I'd be shocked if any of you encountered those. But if you have a script that works in version 2 and has difficulties in version 3, tell me about it, because we want absolute compatibility.
This perf improvement also lights up the scenario where we said the IT pro and the developer can both develop, contribute with commandlets or solutions built on top of commandlets.
By the way, just to get it in focus, we are like crazy about testing and automated testing as PowerShell. You'd think an automation product would be pretty good at that, and we are. We have hundreds of thousands of test cases, and all of the hundreds of thousands of test cases that worked in version 2 work in version 3, so we're very, very confident, but we also know the rich modes of usage that the world will use. So unpredicted usages. So,
all right, let's take a quick look at remote disconnect and reconnect. Let me close my solution. There we go. No GUI for this demo. We're just going to walk through the code. I'm just going to step through it. What we're going to do is the 2 things I described in the slides. We're going to open up a session, run a script on the remote machine, close the session, disconnect the session, sleep, reconnect to that same session. The second part of the demo is going to do the second scenario. Remote machine, disconnect, sleep, tear down the session, recreate, reconstruct the session, and hook up to it. Of course, you need to remember to save your instance ID, otherwise you don't know which instance to hook up to. I hit F5.
Well, yes, but you can always query the machine to find the instance IDs and connect to it that way.
Right, but you have to know which one you want to connect to.
Yeah.
All right. So this is just setting up the connection info. You will notice that we hard-coded the machine name. This machine that we hard-coded is actually this virtual machine running on the box. I can actually tear down all of this. We don't need that anymore. But this is actually the VM. It's on the same box, but it's a VM that we're going to connect to. And we need this guy on the side. I'm really sorry about the resolution. This is not the resolution I was testing the demo on. But unfortunately, we're bound to some resolution that doesn't make this look any better. And let's do that and hope for the best. So this is basically just for demo purposes, the server name is that VM. We're going to step through the code. We're setting up the WSMAN connection, using our run space, opening the run space. We're looking okay, creating the PowerShell object, attaching the run space object to the run space property, the PowerShell object. And here's our script. It basically does a simple count from 1 to 60, sleeps for a second, and then outputs the number that it passes through the pipeline. Right? And this is just the collection where this is what we're collecting our output in, the collection we're using for output. So we're doing a begin invoke. I'm going to unpin my Solution Explorer and properties. Is that a little better?
Yes.
All right, so we're doing a begin invoke, sleeping for a couple of seconds. We're beginning to see output. I'm going to delay, but then we're just going to disconnect from the run space.
Where's the output?
It's on the side, on the right-hand side. It's on the top right.
Okay. Oh, I see. Yep, got it.
So we're disconnecting. Notice that we have 17 items output to the objects output to the pipeline already. And we're checking our run space state and our PowerShell object state, and they're both disconnected, as you can see from the locals window here.
Gotcha. So you're running this code here, you've connected to another machine, you're running a script there.
Correct.
And it continues to run, but you've disconnected
I've
here.
disconnected the session. It's still running on the remote machine.
So you have no TCP connection at this point.
Correct. Yeah. Now, artificial delay, and now I'm going to connect asynchronously back to the same session. Remember, I still have my session. Do a delay, and voila. My count from 1 to 60 is actually all here. I have to pull this back in. I didn't lose anything, even the first 17 that were output, because we're in the same session. Now you're going to have to contrast that with what we're going to see in the second part of the demo. Okay, so let's just hit F5 and go to the clear our console. And move on. All right, we're doing the exact same thing for the second part of the demo up until we disconnect. So I'm just going to zoom through that, not waste time, opening the run space. This is the part where we're saving the run space ID just to figure out which one to reconnect to or to reconstruct and connect to. And then using the PowerShell object, we're, again, running the exact same script, 1 to 60, sleep for a second, output the object, and collecting our output in a collection. And here we do our begin invoke again and sleep. Now we're totally disconnected. Here. We just ran a run space.disconnect. We're totally disconnected. And to verify, let's just check on the run space state and the PowerShell object state. Let's do that and verify that both here are disconnected.
Excellent.
Let's hit F5. I think I have a breakpoint. Good. So before our console.clear, we should be able, we saw 4 objects pass through the pipeline. Those 4 are gone. So if you're building a solution, remember, I'm at work, I'm doing something, I get stuff back, that stuff is gone, unless you save it somehow in your application, in your solution that you develop. So you got to save the instance ID to know what to reconstruct afterwards, and you got to make sure if that output is important to the user, these objects need to be cached somehow, stored on disk or whatever. Okay, so now we clear the console. Didn't have focus there. We're creating a new run space. This is the equivalent of going home and starting up a new session, firing up a new session. But
this could have been run on a different process, a different machine.
Totally.
We probably should have run it on my machine.
Different time zone.
Yeah, perfect.
All right. And here is basically just a for each. Can I F5 after that? Yeah, we have another breakpoint. This is just a for each loop to compare our instance ID with the instance IDs of the run spaces running now. I'm just going to skip through it. And if we find the run space in question, we use the run space. And by the way, this code looks exactly or very similar to the one we used before. But this time we're going to, it's also connect async. So again, the same code, we're using the same code again, but reconstructing the run space was different and identifying which session to connect to. That was the only difference between the reconnect and the reconstruct.
Now here the ID is a GUID, correct?
I'm sorry?
The ID is a GUID.
The ID, I did not even check. It is?
Yeah, the ID is a GUID. The other thing you can do is when you connect, you can give it a name. And you can connect.
Does it have a friendly name as well?
And you can connect via name as well.
If uniqueness is at risk, then of course you're going to go the GUID route.
Exactly, because we can both specify the same name, and we don't deal with that. But
if the idea is for the same person to go home and just
the reality is that because you do the command line experience is the same as the API, so you can do this from the command line. You can connect and reconnect, and there the person's not going to type it. You can type in a GUID, but you go and you create something with the name Jeffrey's connection, and then I'll say connect to Jeffrey's connection. I'll just say, if you use Jeffrey's connection, I'll say, dude, what are you doing? Stop that. Right? But that's different than a product.
Just a second. I'll take the question in a second. And we're just checking on the run state status. Basically opened. It's still open. We haven't closed it yet, and the PowerShell object is completed. So we're just going to F5 through, and that was that part. Your question, sir. So when you actually connect and then fire up the operation and then you disconnect, when do you know optimally that you cannot connect back and get the flow? Do you get any confirmation from that, or just go whenever you want them? Excellent question. I'm going to repeat the question, but let me just finish off the demo here. Please look, I scrolled all the way up to the output, and we're starting at 5. Remember those 4 objects that passed through the pipeline? That's what I was talking about. The question, again, if I may repeat, and correct me if I'm wrong, is when do I know when to reconnect to the session? Do I get an event back? I think maybe I did a poor job explaining the scenario, but the scenario is you want to connect whenever. So in other words...
For this scenario, but in
for this scenario, absolutely.
No, and so in general, the question of, hey, I want to perform something on 10,000, 100,000 machines, when do I know to come back? And the answer is, nope, you got to figure that out. Yeah.
But so how about jobs and checking on jobs?
Yep, that's a different thing.
Yeah, so we'll get to the job demo hopefully, and it's not the same. It's still a push model, not a pull model. So in other words, you're not going to be notified, but you can have a very simple script that actually does the checking for you. And if the job status changes to what you're looking for.
So, I forgot to show you the end of that demo. But now, one of the things we're highlighting is that now eventing works over WSMan. So in the past, eventing worked over DCOM, but not WSMan. It's now you can do these eventing. You can subscribe to events over WSMan. So you could issue the request and then just have a back channel event. When the thing is done, your script runs, fires an event. You could do something like that.
This is actually very cool. So in the GUI that Jeffrey was showing in the SIM client API demo, that last line actually had an indication. They call them SIM indications. It's just events, right? And Jay basically said in that line, whenever the status of any service on that remote machine changes, let me know. So that's actually, that might actually be one of the answers to the problem. Yeah, let's move on. All right, so let's switch back.
Here's mine. Yours. Okay. So Windows 8, so what we're doing here is trying to minimize the cost and effort for you to produce these robust multi-machine, workflow-based, multi-machine solutions. And one of the strategies we use is to use workflow-based solutions. So to program against a workflow, it's the same against programming PowerShell. So one of the things we use is what I call the sacred vow, right? You know, with IT pros, I know that their hair's on fire and the last thing they ever want to do is to learn something. And so our sacred vow to them is learn PowerShell, and we will guarantee we'll do everything we can to try and make things look, you know, use the patterns and the skills that you've acquired over and over and over again so that it's the best investment you've ever made. That's why when you go to produce workflows, it's not some crazy different thing. It looks just like PowerShell. You write a PowerShell function, instead of using the word function, use the word workflow, because then it reuses all their skills. Well, we applied the same pattern here to the developers. So now the Windows Management Framework supports distributed execution of workflows. How do you program against it? Well, you already know how to program against PowerShell. Just program against that. And so it's exactly the same model. Now, when you connect to a remote machine, you connect to a named endpoint. There's a default named endpoint, and the default named endpoint gives you all PowerShell capabilities. But the fact of the matter is, these named endpoints are a name, an ACL, a startup script, and in Windows 8, we now have the ability to have a set of credentials. We've also modified it so that these endpoints can be unique. Everyone connects to theirs, they get their own copy, or shared. Multiple people connect and all share a process. Okay? So what this allows you to do, if you want to program against the endpoint, we have a new standard endpoint called Microsoft.PowerShell.Workflow. And when you connect to that endpoint, you've connected to our workflow engine. How do you invoke a workflow engine? The same way you invoke a commandlet. You say command, PowerShell.add command. You give the name of the workflow, .parameters, .invoke, and you get the objects back. Because a workflow is what? A workflow is a high-level task-oriented abstraction that takes a set of inputs, performs actions, and returns a set of outputs. To us, that's a commandlet. So we make it look just like any other commandlet, just has different semantics. Okay? And obviously a lot richer semantics.
And that's exactly what we're going to demo. We're going to show exactly what Jeffrey was saying. As developers, I think you mentioned something that was really cool. You said, this is consuming somebody else's execution environment. When you invoke a commandlet or a workflow. Somebody wrote a commandlet, somebody wrote a workflow, somebody wrote a script. You don't care about the specifics. You want to have a solution that you can build that can actually leverage all of them without knowing the specifics. And that's exactly what we're going to show here. So, thank you.
Probably want that.
Thank you. Yes, absolutely. And this time we have a GUI. Rudimentary, just to get the point across. What we're doing here is basically entering a command. For demo and simplicity purposes, we just have two parameters. And we can also specify local and remote. Very simple. PowerShell doesn't really care whether you're invoking an application like this one, or whether you're actually going back to the command line and doing something like this. cmd/c dir /o-n. Does everybody know what that means? No? It's old stuff. It doesn't really matter what, to PowerShell, it doesn't really matter what kind of application it's, what kind of command it's invoking. To PowerShell, they're all commands. Native application, script, commandlet. Let's do a get command with a command type of commandlet. And it gives you all the commandlets on the local machine. You can add another parameter that says, give me all the ones that start with the letter M, and so on and so forth. To PowerShell, they're all commands. Let's actually invoke a workflow. So I've created a very simple workflow that does, I think, Win32 computer system as well. Get WMI object, Win32 computer system, and we called it get info. So we're going to type get info, and it does exactly what it's supposed to do. It does get WMI object, Win32 computer system. Now, let's take this a step further and try to execute a commandlet on a remote machine. Commandlet And let's do that on a remote machine. And by the way, you cannot fully, command type workflow doesn't exist in the preview release. So
Yeah.
yeah, so it's a bit broken in the preview version of the release that you have, but there is no workflow type. And we're going to use the SRV one. Actually, let me run it locally first. Oh, it's still here. You see this is a Dell Precision M4400, and the machine name is MSP Demo 2, right? Because I'm going to be running this on a remote machine very soon. Maybe I should start with that while it's still fresh in your mind. Let's run get info. I have the same workflow on the remote machine. Let's try to run that, see if it works. And this is the VM, by the way, the remote machine that we're running against. We're waiting. There we go. It actually says virtual machine, and it has a totally different machine name. We'll see the similarities and differences between running local and running on a remote machine. Let's take a look at the code. Let's start with clicking run. Kill this. All we're doing is basically the same flow. That's what you did in Windows 7 as well. This is what continues to work. Add command, add parameters, invoke. The only difference here is that we just have two parameters for the sake of the demo, and we're piping to outstring so that we actually see the string representation instead of the actual object type. So we're just piping the output to outstring. Here, if the computer field name is not empty, what we do is basically create an endpoint for PowerShell by default. If it so happens that we're trying to run a workflow, we create the other type of endpoint that Jeffrey was just describing, and that's a workflow. Can you see the highlight? The workflow type of endpoint. That's pretty much it. And then we have a collection to receive the emitted objects in.
Excellent.
And we run invoke.
Excellent. So to recap, the APIs for invoking commandlets, you know how to do them, they just work. Now, in addition to invoking commandlets, there's a new type of commandlet, and that's a workflow. And so you invoke that commandlet, it invokes the workflow engine, it can run on that machine, distributed, secure, multi-machine workflows, and you get the objects back.
Sorry.
Okay, yeah. So jobs, we've had PowerShell jobs in version 2. In version 3, we really invested in jobs, and it becomes a full first-class citizen. Jobs are a way to basically take advantage of other people's execution environments, okay? So execution environment. PowerShell is an execution environment. Workflow is an execution environment. Task scheduler is an execution environment. There might be the Tivoli job scheduler is an execution environment. These things are all things that can run long-running tasks or have named tasks, etc. And so you could say, well, the way to deal with that is to treat each thing as its own unique thing and then let the user deal with that ambiguity, and you guys are tough programmers. You can code to each individual thing. And we said, no, no, no. There's a uniformity to this. We have a uniform way to deal with these things. We call it the job model and a job source adapter. So jobs are basically things that run asynchronously. If I just say, run, do this, get WMI object, it returns the objects. If I say get WMI object as job, it returns a job. On a job, I can wait for results, I can get the results, I can stop the job, etc. Now we have a job source adapter that allows us to say, hey, I would like to import the jobs from the job scheduler. I would like to import the jobs from our workflow engine, and they show up as jobs, and on any of those things, I can wait for them to complete, I can stop them, I can resume them, I can receive the results.
Yeah. Thank you, Jeffrey.
And I think I just described all that. We're
That's
running
all right.
short of time,
Sure.
Maybe we show the demo. Anyway, this slide, you want to pay attention to the slide. It gives you some of the details of how, if you have something that matches a job source adapter, how you'd go do that. Source of jobs.
Do I have a minute for
Yeah.
a couple of quick points?
Yep.
what Jeffrey described, just a couple of notes to that. Job source adapter, we're shipping 2 by default in Windows 8. We already said scheduled jobs and workflows are 2 new job types. The beauty of all of this, and that's the last point for this slide, is that in Windows 7 we already had star job commandlets. They will continue to work. Our end users, the IT pros, your end users, will not have to learn anything new. And you can also create your own custom jobs, custom job types. If you feel workflows, commandlets, scheduled jobs are not enough, create your own types of jobs. And they will continue to work as well with the job commandlets. That's it.
Yeah, you know what, now that you said that, now I got to say it. So, sorry, there's so much to discuss in this release, it's crazy. In V3, we now support full support for the task scheduler. So you can say, hey, here's a bit of code that I want to run every Friday at noon. Here's a piece of code I want to run anytime the system starts up or when anyone logs in. And that's a very smooth, easy way to do that now.
And also, new for Windows 8 is suspend and resume.
Of jobs.
Of jobs. Yes, so if you create your own job source adapter, the end user imports the module, you package it as a module, the end user imports the module, and that importing the module automatically registers your custom job source adapter.
Now let's show them. Honestly, we could do a whole conference on PowerShell v3.
Yeah. Simple GUI. Here we have, for simplicity purposes, a script and a workflow. So let's just start by creating a job that runs a script and stopping it. Okay? We can also schedule the script. On success, it pulls up Task Scheduler. I think it's programmed to run in 2 minutes. We have
just to be clear,
PowerShell here.
He brought that up. Scheduling it didn't bring up the GUI. It's all automated. But to highlight what happened underneath the covers, that's what he's showing you.
Thank you. So here we can actually monitor that job. We can also do it from PowerShell. We can just go to PowerShell and do get scheduled job. And it'll actually show you the job that's scheduled in Task Scheduler. And you can do stuff with this. You can actually change the triggers. So, of course, for demo purposes, we have a trigger that fires every day and in 2 minutes from launch. So you can do whatever you want. You can actually stop. You can do a whole bunch of things.
Now this gets amazingly cool. Just put your seatbelts on. Because you know how when you have a job, when you use Job Scheduler, your Task Scheduler, run something and the output goes, I don't know where the hell it goes, but I can never get it back. We give it back to you.
We have a couple of minutes. Did you want to talk about talking? We have to wait. It's
you have to wait. Here, just invoke it. Just do run. You do this, because it can run multiple times. We'll just run it. Ooh, okay. There, ran.
It did.
Now show them what it looks like. Go back to that.
Sure. There's a whole bunch of jobs.
You did get job. Do get scheduled job. Oh, yeah. Oh, I see. Yeah, that's the job results. Yep.
And that was the result. No, receive job. Don't we have to do receive job?
Yeah.
Do get job, receive.
No. Okay, I got everything.
This got everything. So
that's okay. We're running out of time.
Job ID 1.
It's glorious. Play with it. Now let's get this.
Okay.
Let's finish on time.
Sorry.
Yeah, it's great. Go play with that some. All right. Cloud management's automation, cloud management solutions need to manage everything, right? From down-level OSs, hey, this all is great, but the world already exists, and I need to deal with it, and I need to manage everything. Well, Windows Management Framework addresses that. First is we intend to make this available on Windows 7, Windows 2008 R2, and Windows 2008. So we did that with the last version of the Windows Management Framework. We shipped it on Windows 7 and then simultaneously shipped it down level. Our intention to do the same thing, to simultaneously ship it down level. Now, PowerShell remoting, I can just guarantee you it's always going to work. I mean, always, always, always. The earliest version, the very first version of PowerShell remoting, I guarantee you is going to work with PowerShell version 4000. Right? And PowerShell version 4000, I'm going to guarantee you will be able to manage PowerShell, the very first version of PowerShell remoting. That's the way we do things. So even though PowerShell version 3 and the new remoting stuff is not going to go down to XP, PowerShell version 3 on Windows 8, Server 8, will be able to manage XP. Okay? Because the remoting protocol work. So too, XP will be able to manage Windows 8. That's what architects are for. Windows 8, however, is going to be the best managed OS. The 2330 commandlets that we have, most of those are managing unique Windows 8 functions. Those will not go down level. The core PowerShell set of commandlets will go down level, and that's expanded a bit. But the bulk of the things, Windows 8 is going to be the best managed OS. And then something, put your seatbelts on. This is a little bit of a strange story. We are heavily invested in standards-based management. Okay? So we want to use standards-based management to talk to routers, storage devices, any device. And the problem is that those environments don't have a difficult time. They haven't been doing a very good job in implementing the standards, and the reason why is that there hasn't been enough collective, I don't know why, but it just hasn't been. They have a few open source versions of what is called a SIMOM, which is necessary to implement standards-based management, and frankly, they haven't been great implementations. And so, NanoWebM is a portable next-generation SIMOM, SIM server, that implements the key thing. Microsoft wrote it on Linux. Seriously. And guess what? Thing rocks. I mean, it just rocks. So it has exactly the same provider interface as our new WMI v2 provider interface. If you weren't here for the last talk, we have a new way to write WMI providers. It's about an order of magnitude easier. I mean, it's just so simple. And the same way you write a provider in Windows, you can write on Linux. It's a C model. And we're going to make this readily licensable to others. Now, I'm being intentionally vague here because we're working with the lawyers. But the key thing I want to communicate is our intention is to move the industry forward in adopting standards-based management. We're not going to say, hey, I can get an extra couple bucks if I get money from you adopting it. That's not the play. So it's going to be readily available. Read cheap or free. Erase that. Anyway, so now comparison. What are we talking about? Well, here's the Open Pegasus is the thing most people are using today. Our NanoWebM is 76 times faster. I'm telling you, this thing rocks. The object size, 53 times smaller. The provider size is about 10 times smaller, right? The design center was to be able to run this on a phone. Right, or on a device. By the way, it's architected, originally we were going to call it the scalable SIMOM, right? Because it will run on things as small as a phone, but the architecture is such that you can replace this part, and run it on the very largest of systems, right? Put a SQL backend on these things. So this is really quite a neat piece of technology. And again, all the providers you write for this, you can write for Windows as well. So, we are committed to standards-based management. By the way, competitors, not so much. So the call to action is to leverage SIM, PowerShell, and workflow to build powerful, robust, multi-machine, heterogeneous management solutions. We got new APIs to do that. New APIs are always kind of a pain in the butt. When you take a look at the APIs and you code to them, you will realize why we introduced those. It'll be a very good investment of your time. To make sure that it's a great investment of your time, we're making them available down level. We know that if you're writing management solutions, you're going to put it on the latest OS, but you also want to deal with your addressable market. So you want it to be both the things that get managed and the things you manage from are on the widest range of devices, and use the commandlets or for scripting or a combination of these things. And again, part of the thing you should think about this NanoWebM is you're investing investment in the APIs, learning the APIs and building standards-based management solutions, we're investing to make you successful. Because if we can get the rest of the industry to support these standards-based management in a really powerful, meaningful way, then your solutions, you can just say, hey, instead of pointing at a Windows device, point at a Linux device, and it will just work. So we're in your corner. We're trying to make you successful. Not that we want a lot of Linux boxes for you to work against, but one way or the other, we're going to make you successful. So that's our talk.
Thank you.
Thank you.